Hello class, this is a video tutorial on global maxima or minima. Given a function f of x in the domain between x equals a and x equals b, there must exist 2 points within the domain that are the highest and lowest points. These points are called the global maximum and minimum. You may also see them in textbooks referred to as the absolute maximum or absolute minimum. The points are are found as stationary points of f of x or the endpoints of the function. So here's just two quick examples of what this might look like. So we have some function, the green ones, between any two x values a and b. So the function would continue normally, but we're stopping it at these 2 points, a and b. Notice how there has to be a point along this curve that is the absolute highest value. So absolute highest value, that point being here, whatever it might be, let's call it x0 f of x0. Okay, so that is the absolute highest point. And the absolute lowest point, well, there's nothing along the curve, but this point itself, right? The point itself is the lowest point, so this boundary point is the lowest. And so this lowest point here is b f of b. Now this highest point here is the global maximum, global max, or absolute max, and this point here is the global min, global minimum, or absolute minimum. Here's another example here. Can you visualize the absolute maximum and absolute minimum? Well, it's clear to see that this point here is the absolute minimum. Okay, so that is, let's label this point, I don't know, x1. So this point here is x1 f of x1, whatever it might be. And now for the global maximum, well, it's not along the curve itself, so it has to be either this one or this one, in which case it's very clear with the graph that this point here, a f of a, that is the global maximum. So let's get to some actual examples here. Let's calculate the coordinates of the global max and minimum of the following functions on their given domains. So we have the function 4x minus x squared on the domain 0 to 4. So for this, what I usually like to start off straight away with is check my values of 0 and 4. So I'm going to test my, my endpoint. So f of 0, well, that's 4 times 0 minus 0 squared. That's just 0. So 0, 0. Already, this is a possible candidate for the absolute maximum or minimum, because so far nothing is greater or lower than 0. Let's test f of 4. It's going to be 4 times 4 minus 4 squared. That's 16, take away 16, that's also 0. So 0, 0. Again, these 2 points are the same. And for this, it's actually possible to have 2 global maximums or 2 global minima. So now let's test for any stationary point between this. So let's test f prime of x is going to be, differentiating this, 4 minus 2x. Solving this for 0, we get 4 equals 2x, x is equal to 2. So this could possibly be higher or lower than these points. So let's test that now. So f of 2, going back to my original function here, that's going to be 4 times 2 minus 2 squared. This is going to be 8 minus 4, which is 4. So this is going to be 2, 4. In which case, looking at our 3 critical points, it's very clear to see which one of these is the highest point. In case you didn't see it, to find the highest point, we look at the y value. So this is clearly the highest point. So this is our global max. And these 2 points collectively, because they are the exact same points, oh sorry, they shouldn't have been 0, 0. This should have been 4, 0. Glad I caught that. These 2 points have the same lowest values being 0. So that must mean these 2 points, both of them, both are global minima. Global min. Let's do this one more time. Let's find the global maximum or minimum of this function between this domain. So first, we should always test the endpoint. So let's do g of half. I'm not going to write it out. I'm just going to substitute it straight away. So we get half to the power of 3 minus 6 times half to the power of 2 plus 9 times half minus 4. That gives me negative 0.875, so negative 0.875. So this point here is half negative 0.875. Let's test g of 5. So it's going to be 5 cubed minus 6 times 5 squared plus 9 times 5 minus 4. That's going to give me 16. This is 5, 16. Already these 2 points, one could be a global minimum. This one here could be, because that's already the lowest point. And this could be the global maximum, because that is the highest point. What we need to do now is check that any of the stationary points between here aren't lower or higher than these 2 points already. So for this, let's find the derivative. G prime of x is equal to 3x squared minus 12x plus 9. Let's solve this for 0, equaling 0. I'm going to divide everything by 3 first. Dividing everything by 3, we get x squared minus 4x plus 3 is equal to 0. This will give us x minus 1 and x minus 3, which means we get x equals 1 and x equals 3. Now we need to test the values of these in our original function. So that's g of 1. Let's test this one out. G of 1 means 1 cubed minus 6 times 1 squared plus 9 times 1 minus 4. That gives me 0. So this is 1, 0. Let's test g of 3 now. 3 cubed minus 6 times 3 squared plus 9 times 3 minus 4. That gives me negative 4. So these are all the values that I need. This is going to be 3, negative 4. Let's highlight all the key points that we need. Now for this, it's slightly harder. Let's just think about the highest. Let's do one at a time. Let's do our global max. Let's take a look at all the y values and see which one is the highest one. So negative 4 is low, 0 is higher. Well, it's clearly going to be that one because that is the highest point at 516. So our global max is at 516. Our global min now all we need to do is look at our lowest points. So that's negative 4 is our lowest. Well, negative 0.875, it's not even close. So our global minimum is at 3, negative 4. So I hope that gave you an insight into calculating the global maximum and the global minimum on a function between a domain. Hope to see you in the next video. Best of luck.